So I'm going to explain some questions that involve AP and GP. But the thing is, right, there's a lot of types of questions that involve AP and GP, so I can't go through it all. So I'm only going to explain some. However, the best thing that you need to know is that you need to actually do it yourself for you to actually understand what I'm saying here. So you can do the things that I'm not teaching in this video, and then you can also try and do the K-bar stuff. But if you don't know how to do the K-bar ones, the very hard ones, um, which involve AP, GP, and Sigma, then you can watch the video in my YouTube channel, which was a few days ago, I think. So yeah, there's going to be I'm going to divide this into 3 stages: stage 1, 2, and 3. This is stage 2, and I'm going to discuss some of the questions in this thing. So the first one I'm going to discuss would be this one. So the reason why I want to talk about this one is because it involves one of the things that I said earlier, which is um let Tn be less than 0, because you want to find the first negative term. So you want to let Tn be less than 0. So use A plus n minus 1 d. I'm not going to solve the thing literally. I'm just going to tell you what is the formula that you need to find the solution. So in this case, you have to find A plus n minus 1 d. And you want to find n. So you see here, after some playing around, you find d, you find a, you will get n minus 1 is greater than 2000 over 23. So n equals to 8722 over 23. Not equal to, greater than. So if you see here, it's less than, but after that it becomes more than because of this negative sign here, I think. So yeah. Yeah, it is because of the negative sign. So you have to be careful when you're doing this the long working for it. So after you get this, you want to find the first integer, first natural number, because n is an element of natural numbers. N is a natural number, so the first number will be 88. Okay, the next one, let's see if I can. The next one would be this. This one is the reason why I want to mention this one is because it mentions 3 sides. So when you mention 3 sides, the first thing that you want to think about, it would be you want to let your sides become a minus d, a, and a plus d. And that is because if you were to add these 3 together, you will get 3a. So you will not need to use the d anymore. The d wouldn't be needed when you're adding them together, but you still need d because the d proves that they are an AP, because remember, these are in AP, so a minus d equals to d, right? So it proves that they are an AP because they have an equal common difference. So yeah, that is for method 2. So method 2, after you get these 3 sides, you know that the longest side will be a plus d, because and you add a value, it's certainly going to be bigger, right? So the biggest value is a plus d, or in this case b plus d. Then you square it out. So when you square it, then after that you will do the equation. Then you will get b equals 0 or b equals to 4d. But you know, in a triangle, your length cannot be negative, it cannot be 0, because if your length is 0, then the length then this side, then your side isn't there, if you get what I mean. So you need more than 0, so 4d. So b equals 4d. So since b minus d, b plus d, so b minus d is 3d, b minus d is 5d. So 3d, 4d, 5d. So there are in the ratio of 3, 4, 5. Okay, yeah. It has to be B in this case because it already gives you sizes A, B, and C, where B is the middle number. So you want B to be a middle number, that's why you have to use B. Okay, so how about the other method that they use? The other method that they use is actually using arithmetic mean, as you can see here. But it also uses Pythagoras, which is a squared plus b squared equals c squared. So you will get 2 equations. After you get these two equations, you wanna get a third equation. So what you do is you divide this and by this. You divide 1 by 2 because CA, so you'll get C minus A equals to B over 2. This solve 1 and 3 means, right, it completely skips the summing out thing. So what I mean by that, if I were to multiply 3 by 2, no need to multiply. If I were to do 3 plus 1, then I will get A plus C minus A. So 2C equals to 2B plus B over 2. So that is, I believe, 5. So 5 over 4B. Because 5 over 2, then 2 brought down, so it is 5 over 4B. And then A equals to 3 over 4B. So when you do that, you will get a ratio of 3B over 4B, 5B over 4. Cross out the B because they're common, times it by 4. So it's 3, 4, 5. So, and that is the proof for the ratio. Next one is the reason why I want to mention example 20 is because a lot of people sometimes think a bit too complicated, but this question is one of the easier ones. So you might wonder, how the heck do I get 16 terms? Now you know that they give you the general term Tn, so you can let n be whatever number you want, and you can sub n in here as well. These n are related. So T16 is equal to 7 times 16 minus 5, which is equal to 107. And then we use the formula n when Sn equals to n over 2a plus l. So we're going to find a as well. So we sub in with n equals to 1, n equals to 16. Then we will get 872 in the end. So that's a very short one, but it's something that you need to remember about. Now we're going to go through the GP questions. So GP, this is a very common one where they give you a square. So they give you a square with increasing areas. So the areas actually increase in GP. So how do they explain the areas? So they explain that the length is AD, right? After that it halves, and then it keeps halving, and then it keeps halving. So at first thought you will think that r equals to 1 over 2 because it keeps halving and halving and halving. But that's not the case, because you have to remember that here, half as well. So it is decreasing at two areas. So because of that, you need to find the area of the square first before you try and determine the common ratio. So you let the length be a, so it's a square, and then you let the second one be half of a. So half of a times half of a is 1 over 4 a square, and 1 over 16 a square. Then you will find out that r equals to 1 over 4. So yeah, this is another one that looks very complicated, but it's actually very easy. You just have to try and find the area before you determine the final ratio. Remember, when you're trying to prove what the ratio is, you have to make sure that T over 2 R1 equals to R2. So T2 over T1 equals to T3 over T2. For AP, if you want to prove that D1 equals to D2, then T2 minus T1 equals to T3 minus T2. But that's how you do a general proof of AP and GP. Next one is similar to the first one, where we have A minus D, A, and A plus D. But GP is a bit more complicated, but it has a similar concept, which is A over R, A, and AR. The main reason why you want to use that is because you have to mention it mentions the product here. So it mentions the product. Since it mentions the product, if you multiply all of them together, you realize that you can cut R out. So you will get A cubed equals to 512. A cubed is equal to 512, thus A equals to the cube root of 512, which is 8 here. And then you can put 8 in your value, so you will get 8 over R plus 8 plus 8R, as you can see here. Now, if you realize the sum of all of this is equal to 28, But the thing I want to point out here is that you see there is r and r here, so you can actually turn them into a quadratic equation because there are two powers ahead of each other. What I mean by that, if I were to multiply the whole thing by r, I will get this 8r squared minus 20r plus 8 equals to 0. You can see that there's r squared and then no r here, so there's a difference level of 2, so you can turn it into a quadratic equation. So after that, you factorize, and then what you will get is two answers, which are at the back, 1 over 2 and 2. Now, these two are both accepted because the thing is that you want to find three numbers in GP, but you do not know if they are in increasing or decreasing order. If you were to use this, they will be in increasing order. If you were to use this, they will be in decreasing order. But the main point here is that the numbers are the same. It will be 8, 4, and 16. So yeah, it's either going to be 4, 8, 16, or it's going to be 16, 8, 4. It doesn't mention if it's increasing or decreasing, so you can use both of them as the answer. But you must mention that both of them are the answers. Okay, the last one that I want to mention is also similar to another one that I just discussed, which is trying to calculate a value that is more than a certain number. So the reason why here is 1000 but here is 100,000 is because we're trying to convert them into cents. So these are all actually 100,000 cents. The reason why I want to use 100,000 cents is because they gave cents here. Cent. So since they give cent, I want to try and convert the ringgit into cent as well. You can also convert cent into ringgit, but that will involve decimals, and if you do not like decimals, then I prefer you to convert them into cent. Then you find out what's A. A is the first value, R is the ratio, like times 2 times 2 times 2, so R is 2. And then you need to find the first value that is more than 100,000. Then you use the SN formula because you want to find the total amount of money. If it's TN, it means it is the first time the amount of money becomes more than 1,000. But if you want to find the total amount of money, then you have to find the sum of the money, SN. So SN is greater than 100,000. You submit the formula. And the main thing here is that after you do your normal stuff, you will get this type of thing. You see that there is 2n here. So how do I solve this 2n? So what I want to do with this 2n is I want to make sure that the 2n is alone on one side. And I want to bring the other side to be a whole number. So you can see it's minus 1 and 220,000. So I bring that 1 there. So I will get 20,001. Then I want to use log 10. Log 10 or LG is equal to log 10. So or just log, normal log. So log 2 equals to log 20,001. So the reason why I want to make log 2n is because if you remember correctly, log a power b is equal to b log a. So because I can take the n out now, so n log 2 equals to 20,001, as you can see here. And after that you divide, so you will get n is greater than 14.29. And remember, we want to make it in an integer value, so n is equal to 15. But however, the main thing that you need to remember here is that you need to make sure that your log is actually positive or negative. Because if it's negative, remember that we are talking about inequalities here. So you have to flip the sign if it's negative. One tip that I can give you is if your log is less than if your x here, if x is less than 1. Yes, it is. Okay. If x is less than 1, then log x is negative. So yeah, the reason why it's negative is because normally these things involve decimals. So like square root of 2, not square root of 2, yeah. Yes. Wait yeah, not square root of 2. If you if the decimal value is less than 1, it will be negative, because normally when your decimal value is less than 1, it means it is in fraction form or decimal form. So 1 over 2 squared is 1 over 4, and it keeps getting smaller and smaller and smaller. But the reason why it's negative is because you can actually write it as 2 power negative 2. So you can see here, this is the negative part, and that's where the negative comes from. But yeah, just one tip. You either want to remember that anything below 1 is negative, or you want to try and convert the value into their decimal form first before you divide, so you don't actually end up dividing without changing the sign. Because if you don't change the sign, if you have to change the sign, the whole thing will be wrong and you will get you will lose marks. But this thing's this question is very forgiving, because if you want to go exceed for the first time, it has to be more than. You want to get the first number that is more than. If you get less than, then it wouldn't make sense if you think about it more. I'm not going to mention why it doesn't make sense, but if you think about it more, it will make more sense. So you will realize that you have to change the thing. But again, just a reminder, be careful of your logs. Make sure that it is in positive value. Now, one more thing that I want to mention would be that during an admaths test that I took, there was a question about folding papers. And I'm going to see if I can find that question again, because that question caught me off guard and I got careless in it. And I'm going to write it down so I can give you guys an explanation about why I got it wrong. So give me a second. I can't really pause this video. So I'm gonna. I think I found it. Yeah, give me a bit. Okay, a piece of paper is 0.2 mm thick, and it can be imagine it can be folded as many times as possible. So, and it doubles every fold. So it doubles every fold. So R equals to 2, right? Obviously. So that means after the first half fold, then the paper is 0.4 mm thick. How thick is the folded paper after 10 folds? So you have to be careful when it comes to this question. The keyword here, if I remember correctly from my friend, is the word after, because you have to be careful with this. You will assume that T1 is equal to 0.2. However, let me just look at this again. This is actually wrong. The first term is actually 0.4. Because we assume that this is actually T0. So this is the part where it gets a bit confusing. So why do we have to start at 0.4 instead of 0.2? Because after the first fold, so T0, then first fold, it will be 0.4, and then second fold, after that, then it will be 0.8, and so on. So after 10 folds, then you will get T10. So this is 10th fold already, because remember, first fold, second fold, now it's the 10th fold. So because now it's the 10th fold, then you will get 0.4, because remember, you want T1, so 0.4 times 2 power 9. And that is the correct answer. Because if you were to use T0 as your first term, use T0 as your first term. So let's say T1 is equal to 0.2, and then borrow first fold, and then so on. If you realize correctly, T10 is equal to 0.2 times 2 power 9. But then your 10th fold is after your 10th term. They're asking to find after 10 folds. Since they're asking to find after 10 folds, you need to find the fold after that, which is T11. And finding T11 after 10 folds, even though you can do it, I wouldn't recommend it because it gets confusing. So you want to try. So when you see the word after folds or after a bounce in the UEC book, they mention about a bouncing ball, like it bounces, and then after how many bounces. That is also similar because it also applies this after thing where you need to make sure that you got the sequence right. You need to make sure that your term comes after the fold. If your term comes before the fold, then this T10 here isn't actually T10. You're supposed to find T11, but that's confusing because they ask for 10 folds only. So yeah, you need to be very careful when it comes to a question like this. For me, I will recommend you to just write it in a small area, so like 0.2, 0.4, 0.8, so on. Fold, 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 and then you try put here T0. You probably put here T1. So T2, T1, T2, T2, T3, and so on. 1 fold, 2 fold, 3 fold, and then you looking at it at fold number 10. You see what comes up. You see what comes up after that. So fold T0, 0, 1, 0, 1, 1, 2, 2, 3. So he'll be T9, and then he'll be T10, and then he'll be T11, and he'll be T10. So you see what I'm saying here. They want after 10 folds. So if you want to find T10, you need to make sure that that your first term starts after folding. Like there is no harm in starting with starting with this 0.2, but you need to keep in mind that the 0.2 is the starting point, and there were no folds before that. Since there were no folds before that, you need to and you want to find what is the length after the 10th fold. Then after you find your first 10 term, you need to find what's after T9, because after T9 is the 10th fold, which is not T9. After T10 is the 10th fold, which is T11. So yeah, I'm just repeating myself right now. When you see this after or before questions, you need to make sure that you get the pattern right. Try and calculate a pattern. I know this is 10 because 1, 1, 2, 2, 3, 3. 1, 1, 2, 2, 3, and then T3. So 10 and then 10. So after the 10th fold is the 10th term. So I know that T1 is equal to 0.4. But yeah, there is a question about bouncing balls. I just look at the exercise, and then I think you'll be able to find it. If you the next video is going to be about kebat, but I already made it actually because I thought I wouldn't be teaching this whole thing, but I'm gonna teach it anyway.